Hi everyone, this is Tim Young with Elevate Software, and this is an Elevate Web Builder 2 tutorial video. Elevate Web Builder 2 is a rapid application development environment that allows you to create beautiful, full-featured web applications that run in any modern browser. In this tutorial video, I'll be creating a progress bar control. While this may not be representative of the construction process for more complicated controls, it should give you a better understanding of the basic steps involved with creating a visual control. Let's get started. The first step when building a new control is to create a skeleton class that outlines the basic properties and user interface elements that will be in the control. We'll use the New Component dialog to start creating the skeleton class. The New Component option can be found on the Library menu in the IDE. In the New Component dialog, we'll specify the class name for the control. In this case, we'll use tProgressBar as the class name. One major caveat here, though. The release version of Elevate Web Builder 2 already includes this control as the tProgressBar control. So, if you're using the release version of Elevate Web Builder 2, then please use a different name for the control here, such as tProgress, and then substitute the new class name whenever I mention tProgressBar elsewhere in the video. Next, we'll need to select the ancestor class name for the control. We'll go ahead and select the tControl class as the ancestor. And we'll click on the OK button to create the unit for the control. Now that we've got an outline of the class created, we need to start defining the member variables, methods, and properties for the class. For the sake of brevity, I'm going to go ahead and use a unit that I've already created. We now need to determine how many user interface elements will be required by the control. Each user interface element in a control has a name that is unique within an instance of the control class. The base tControl class automatically creates a container user interface element named base, and in some cases this can be sufficient for a control. But in this case, we're going to need another element which we'll call bar element. And we'll add a protected property for the bar element in order to give descendant classes access to the element, in case they wish to customize the element further. At the bare minimum, any visual control will need to override two ancestor methods. The first method is the initializeProperties method of the ancestor tComponent class. This method is used to initialize the control's interface state. As you can see, we simply initialize the control state to the normal state. While you can use any state that you wish here, you should stick with the normal state in order to be consistent with the included Elevate Web Builder controls. The second method is the getInterfaceClassName method of the ancestor tInterfaceController class. The control interface name returned by this method is used by the interface manager in Elevate Web Builder to look up the visual control interface and apply its various states to the control. We will be creating the visual control interface after we're done reviewing the declaration and implementation of the progress bar control class. In most cases, the value returned by this method will simply be the class name of the control, and here we use the static tObjectClassName method to return the class name for the tProgressBar class. As previously mentioned, many controls will simply consist of a single user interface element that is auto-created by the base tControl class. However, the progress bar control will require a second user interface element, which we've called bar element. We will need to create this element using the createInterfaceElements method of the ancestor tInterfaceController class. The Interface Manager Create Element method allows us to create a user interface element at runtime or design time. The Create Element method accepts three parameters: the name of the element that we're creating, the parent element for the new element, and the class name for the element. We'll need a constant for the name of the bar element, which we'll put in the constants section of the unit. The assigned parent element becomes the owner of the element and will automatically destroy the element when itself is destroyed. Because we're assigning the base element here, this means that both elements will automatically be destroyed when the control instance is destroyed. The element class name is used by the Interface Manager to determine what type of user interface element to create, both at runtime and design time. In this case, we're creating a simple container element just like the base element for the control, so we'll use the predefined div element class name. Finally, we need to override the update interface state method of the ancestor tinterface controller class. By default, Elevate Web Builder automatically handles most of the control state transitions for you, using standard state names for normal, hot, focused, pushed, read-only, and disabled states. This step is simply a performance optimization for controls like the T-Progress bar control that don't need to have their visual appearance change based upon events such as the mouse hovering over the control. At this point, you might have noticed some other properties and methods in the T-Progress bar control class declaration and implementation, such as the fill property and the getFillGetter method. These properties and methods are simply shells around the underlying user interface elements that expose certain interface properties so that they may be customizable by the developer. As you can see with the getFill method, we're simply surfacing the background fill property of the underlying bar user interface element. This is important when writing visual controls, since it minimizes the need for the developer to create custom descendant controls simply to alter their appearance in some way. Okay, now that we've dealt with the user interface elements, let's move on to the core progress bar functionality. We'll need three pieces of information for a progress bar: the minimum value for the progress range, the maximum value for the progress range, which we'll initialize to 100, and finally, the current progress position. We'll then need to create setter method declarations for the min value, max value, and position properties. And we're going to need a common method for handling changes to the progress bar, which we'll call doChanged. We'll make it protected and virtual, thus giving any descendant classes an opportunity to override how the changes are handled. The final touches on the class declaration will be the published properties for the progress bar control. You'll also notice that there are quite a few other published properties and events here. These are existing protected properties that are defined in the base T-Control class, so we only need to publish them for the T-Progress bar class. The specific T-Control properties you will publish for a given control will depend upon the functionality that is required by the control, but most controls will, at the very least, need to publish the dimensional and layout properties, such as the top, left, height, width, and layout, as well as the standard moving, sizing, and mouse events. Okay, so we're done with the class declaration. Let's move on to the implementation of the T-Progress bar class, starting with the setter methods. The setter methods simply check for changes to the min value, max value, and position properties and call the doChanged method if one of the properties has changed. The doChanged method performs some range checks on the property values and then modifies the width of the bar element so that it equals the position property scaled to the client width of the base element. That's it for the code for the progress bar control, at least for now. We can actually install the progress bar control into the component library now, but because we haven't defined a user interface for the control, it will simply appear as transparent blank space. We'll go ahead and install the control though, just to make sure that we haven't made any coding errors and that the control is usable at design time. We'll use the Add Component dialog to install the progress bar control into the component library. The Add Component option can be found on the Library menu in the IDE. In the Add Component dialog, we'll specify the class name for the progress bar control. We'll then select the progress bar unit that we've created as the unit where the tProgressBar class is declared and implemented. We'll leave the progress bar control in this default standard category of the component library. And finally, we'll go ahead and select an icon for the progress bar. I've already created one in the same folder as the progress bar unit. Now we can click on the OK button and rebuild the component library. Let's go ahead and create a new project and check out the progress bar control at design time. We'll click on the tProgressBar control on the standard page of the component palette and then create an instance on the form. As you can see, the progress bar control is present and you can modify all of its properties, but the control remains transparent because we haven't created an interface for it yet. The last step in the construction of a visual control is the creation of the control interface. We'll use the New Control Interface menu option to create a new empty control interface for the progress bar control. The New Control Interface menu option can be found on the File New menu in the IDE. Creating a control interface is a fairly simple process. Every control interface consists of an interface class name, which in this case is tProgressBar, and then one or more states. In the case of the progress bar control, we're simply going to create a single interface state called normal. As you can see, the default base user interface element is created for any new state. Okay, so let's now design the base container element. But first, let's revisit a key point about user interfaces. By default, all controls in Elevate Web Builder are initialized using the normal interface state. This is a customary behavior, not an explicit requirement. You can actually initialize a control using any interface state that you wish. Regardless of which interface state is used to initialize a control, when the control is initialized, all of the properties of the interface state are applied to the control. In other words, how we design the normal interface state in the progress bar controls interface will determine the progress bar controls default size and appearance, both at design time and runtime. So let's start with the default width and height. Since this progress bar is simple, we're going to assume a horizontal orientation, and therefore the default width should be larger than the height. We'll also need to set the background of the base element to white. We'll now add the border to the base element. In order to match the default look and feel of Elevate Web Builder 2, we'll use a standard 1 pixel wide gray border with a corner radius of 4 pixels. The last modification required for the base element is the padding. This will be used to slightly offset the bar element from the border of the container base element. We'll use 4 pixels for the padding on all sides. That's it for the base element. Now we'll move on to the bar element. We'll create the bar element by clicking on the New Element Toolbar button and then adding the element to the base element. And we need to make sure that we give it the same name that we did in our code, which was bar. Let's give the bar element a nice gradient background. This is the background that will be used for the progress, so let's make it something that stands out a bit. Okay, so one last step and we're done with the interface. We need the bar element to stick to the left side of the container base element's client area. To accomplish this, we'll modify the layout properties of the bar element. We'll position the bar element at the top left, and then we'll tell it to stretch to the bottom. And finally, we'll set its width to 0 to make sure that the width matches the default progress of 0. Now we just need to save the interface to disk in the same location as the progress bar unit. Let's move back to the progress bar code for the final step of this entire process, the binding of the interface into the code. This is simply a matter of using a compiler directive. We can now rebuild the component library. The build option can be found on the library menu in the IDE. Let's go ahead and create a new project and check out the progress bar control at design time again. As before, we'll click on the T-Progress bar control on the standard page of the component palette and then create an instance on the form. As you can see, the progress bar control is all done, and if we modify the position property, we can see the modifications at design time. And to show progress at runtime, let's go ahead and add a T-Timer component to the form and set it up to modify the T-Progress bar control. Finally, let's go ahead and run the application in the browser. And that's how you create a progress bar control in Elevate Web Builder 2. A link to a zip file containing the source code for this tutorial can be found in the description below the video. Also, as I mentioned at the start of the video, the T-Progress bar will be part of the release version of Elevate Web Builder 2, so you can find the source code for it as part of the included component library. As always, please feel free to contact us at any time with any questions or comments you may have, and thank you very much for your time.